Hi there, in this video you are going to see on how to develop a machine learning agent with LangGraph. So this is basically a multi-agent architecture which is going to have a supervisor agent which is going to plan the strategy, it is going to evaluate the results, and it is going to pass the work between various agents. And you have various agents such as data exploration, data preparation, model training and testing. Now let me also show you on visually how the flow would look like. So the machine learning multi-agent architecture will receive a task, and this task is to build a breast cancer classifier, and the target is to achieve an accuracy of more than 96%. So this task is going to be taken up by the supervisor agent, which is going to plan on what needs to be done. And then based on the plan, it is going to pass the work to the data exploration agent, which is going to do the data profiling. And it is going to calculate various things such as class distribution, missing values, etc. etc. And then the work is going to be passed to the data preparation agent. And the data preparation agent is going to apply various strategies of preparing the data with few features as well as the complete feature set. The work will be then passed to the model training agent, which is also going to apply various strategies such as logistic regression or random forest. And then it is also going to use the large language model to see on what needs to be done if the accuracy is below the threshold of 96%. Now, if the accuracy is below 96%, in that case, the work is again going to be passed to the supervisor agent, which will then decide on what needs to be done. If the accuracy is above 96%, in that case, the work is passed to the testing agent, which is going to make the final accuracy measures, and you are going to end the process. Now, during all these steps, you will have a state variable, which is shared between all the different agents. So all the agents are going to write to this state variable, and the supervisor agent is going to read information from the state variable in order to decide what needs to be done at every step. Now let us see the Python code implementation behind this. So you will need to import packages such as scikit-learn as well as langgraph. And then this is the state variable, which is going to be used to share information across various agents. So this state variable has got the dataset information, the data preparation information, model result, test results, as well as supervisor memo, as well as it also has got information about the reasoning log. So supervisor memo and reasoning log is based on all the activities which are done by sub-agents, and this is very useful because the supervisor is going to read the reasoning log of all the agents, and it is going to decide on what needs to be done at every step. Now let us see also on how the different agents are configured. So all these different agents are going to use a large language model, and here I'm using OpenAI, so you also need the OpenAI key for this. And let us now first see the data exploration agent. So all these agents will receive this state variable, and the data exploration agent is going to load the data set. In our case, this is the breast cancer data set, but you can use any data set of your choice. It is then going to get information related to the data exploration, such as what are the different feature names, what are the target names. It is going to calculate the class distribution, missing values, and then it is going to prepare a prompt and going to pass this data set information to this prompt, and then call a large language model, which is going to give information about data exploration in a very textual way. And this is also called as a reasoning log. And this reasoning log as well as the supervisor memo are going to be returned so that they will be updated into the state variable. So this pattern of updating the reasoning log is done for every agent, and the supervisor agent is going to read this reasoning log to decide on what needs to be done. Now similarly, you have the data preparation agent, which also receives the state variable. And then the data preparation agent is going to prepare the data, such as it is going to split the data set into train and test, as well as it is also going to apply various strategies such as making data preparation with 10 features or more complete feature set. And once again, it is preparing the data, and at the same time, it is also passing the data preparation information to a large language model, which is again going to convert all the information, data preparation information, into a reasoning log, and then it is going to update it back to the state variable. So as you can see that all these agents are communicating with the supervisor through this reasoning log. Now similarly, you have the model training agent, which is going to once again receive the state variable, and it is going to do the model training. So model training can have various algorithms such as logistic regression or random forest classifier. It is also going to find out the accuracy, and then it is also going to call the large language model with all the accuracy results, and then it is going to ask the large language model to analyze the classification report, as well as if the accuracy is below the threshold, which is 96%, it is also asking on what are the recommendations for the data preparation agent. Once again, it is going to pass all this information back as the reasoning log. And then you also have the testing agent, which is going to be called if the accuracy is achieved above 96%. And this testing agent is just going to calculate various accuracy measures such as the confusion matrix as well as the accuracy measures. And once again, it is going to update the state variable. Now let us see on how the supervisor agent looks like. So supervisor agent has got this prompt that you are a supervisor agent and you have all these different sub-agents, and this is going to be your router logic. So for example, if the data set information is empty, it means the data exploration is not yet done. So you should call the data exploration agent. Similarly, for example, if the model has failed and the accuracy is less than 96%, you should again pass the work to data preparation. But in this case, because you already have the instructions which are given by the model training agent on what needs to be improved, it will also ask the data preparation agent to take those specific improvement instructions into consideration. Now the supervisor agent is basically reading all the state variable information and it is just appending all the information, and then it is going to call the large language model with the prompt which I have shown you earlier, as well as all the information which is coming from all the different reasoning logs. And based on that, it is going to create this decision variable. This decision variable will have the complete reasoning, as well as it will also have what is the next agent to be passed. So the next agent information will be returned, as well as it is also going to return what is the instruction for the next agent. Now once all agents are created, you can create the line graph. So this requires building a pipeline. So you are creating a state variable, and then you are adding all the different nodes such as the supervisor agent, data exploration, data preparation, model training and testing. You are going to set the entry point as the supervisor, and then you are also going to add a conditional edge. It means that where the work is going to go from the supervisor agent. So here we are using this variable called as root supervisor, which is basically coming from the next agent state. And if the next agent is data exploration, the work is going to be passed to the data exploration agent. If the next agent is data preparation, in that case, the work is going to be passed to the data preparation agent, and so on and so forth. Now, you also need to add the fixed edges between the data exploration and the supervisor, as well as data preparation, model training supervisor, and testing and supervisor. So the work can be routed back also to the supervisor agent. Now, once you have built the graph, it is time to execute the graph. And as you can see that at every step, you will see how the agent is working. So for example, it will start with the supervisor. And then the supervisor is first going to see that the data exploration has not been done. So the work needs to be passed to the data exploration agent. Data exploration agent is going to explore the data. It is going to come out with these reasonings such as information about data quality, class balance. So here, for example, it has found that the class is imbalanced. And it will also come out with different pre-processing recommendations. So this task reasoning will be then taken up by the data preparation agent, who is going to see all the reasoning which has been done till now, and it is going to apply all the various data preparation techniques such as feature selection, data splitting, etc., etc. Then the work is going to be passed to model training. So model training will do the first pass, and in the first pass the accuracy is 91%, which is less than 96%. So it means that the work has failed. So the model training is also going to then give a recommendation on what needs to be done in order to improve the accuracy. So for example, it is going to tell you what are the recommendations for the data preparation agent. Once again, all this is stored in the reasoning. So the machine learning agent is going to have some recommendations for data preparation on how to improve the model accuracy by better preparing the data. So the supervisor is again going to take back the task, and it is going to pass all the information about how to improve data preparation to the data preparation agent. And this loop will continue, and you will see that the model performance is going to improve at different steps. And at the end, you will see that the final accuracy which has been achieved is 95%. It is not 96%. It is below the threshold. But because we have exceeded the maximum number of iterations, the agent is going to end. So even though we have not achieved 96%, but we have gone from 91% to 95% all in an automated way. So this is a very good example on how a supervisor agent is using large language model to reason based on the tasks and activities which are done by sub-agents and improve the complete process. So if you like this video, please consider following as well as subscribing to the channel. And let me know in the comment below what are the different use cases you see where you can use reasoning and planning to achieve a complex task. So keep learning, keep watching, and see you soon in the next video. Thank you. Bye.